Hi everyone, in this video we will see the HART function in the DPI 620 Genie multifunction calibrator from Druck. We will see how to connect the HART devices to the calibrator, how to perform the communication, and how to browse or navigate through the functions in the HART menus. We will be communicating with Yokogawa YTA temperature transmitter. We did a calibration for that transmitter last video and we found some errors. So the purpose of this video now is to go and make the adjustment. The error was increasing as we are going up, means that, or we suspect that there is a full-scale error in the transmitter. The transmitter settings is 0 to 100 degrees Celsius. The input is RTD-PT100, 2 wires. So I recommend you go and take a look at how did we do the calibration in the last video and how we got to analyze the results, and we found that the error is outside the tolerance set by us. So let me stop the analysis which we started last video and we'll go back to the main menu. So this is the dashboard for the DPI 620 Genie. Let me just disconnect the leads to show you how we connect from scratch. So to go to the HART function, this is the icon, we press on that, and this is our HART menu. We can set up channel 1 and channel 2 to the parameters we want. As we know, the HART communication requires a HART resistor and requires a power supply for the transmitter if the transmitter is not already powered from the network. So we have a couple of variants or a couple of functions we need to set up. So in my case, my transmitter is disconnected from the network. There is no resistor in the leads and there is no power supply. So I have to add a HART resistor and I have to power it up. Because we have a power supply in our Genie, we have an internal resistor as well. We can communicate without need for external resistor or external power supply. The power we can get it from channel 2. So here on channel 2, we wanted to measure the current and we put the current with the 24 volt or 28, depends on the impedance of the device. So let's go with the 24 volt now because it's sufficient for our device here. And in the HART section, you have the settings here. Here you have the option to add or to remove the HART resistor. It is already added here, as you can see the symbol. If you are connecting to the network, you simply remove it, so it will go. In this case, we wanted the HART resistor. So once I'm done with my settings, I will connect my test leads. In the DPI 620 Genie, the channel 2 is the right channel to do the HART communication. It's different in the DPI 620 Genie IS because of the third port here. We have different configuration, depends on the condition we connect to. So I will have a separate video on how to connect HART on Genie IS. So let's connect our device to channel 2 now. So the power supply is inside, the HART resistor is inside. What I have to do is just connect my device and the communicator is also inside. So the transmitter power is up and it's giving me overrange because the input is not connected. The input I already configured it to the RTD, so I can connect it or I can communicate without connecting the input, that's fine. But the reason I'm connecting the input is to show you how I can utilize the calibrator with communicator together. So this is our transmitter. It's giving 4 milliampere at 0 degrees Celsius, just to give you an indication about the error. So this is the 100 degree on the input, gives us 19 84 milliampere. So this is outside the tolerance, and we should go and make the adjustment. Okay, let's take it back to 0. So this is the HART channel. We have two applications actually. We have the HART online and we have the HART offline. The HART offline, we can use it if we wanted to work offline. So we will import the data from the transmitter, make the settings offline, and paste it back or send it back to the transmitter. We can do this to clone devices, or we can just use it as an offline mode. This is so helpful in the initial commissioning, but if the device is already in operation, we need actually to connect to the HART online. So here are the connections, and I'll be just zooming in the screen to make it clear. So I'll press on the HART. Now the device or the communicator will start scanning or searching by pole address. They found my device on address 0, so I'll just press OK. This will take me to the HART menu, where I can start and do the adjustments or the programming. Okay, this is the main menu. It will appear like a tree. So this is the online. Here is the tree. Here is the taskbar, and here is the values. Any value in red, I can't play with it. It is the value came from the transmitter, so it's the measured value. The values in blue are the values which are coming from the calibrator, because we have a calibrator and communicator in the same device. The values in black is the values which can be adjusted on HART communicator. This will vary from a manufacturer to another, depends on what's the area the manufacturer is giving you to adjust on HART. So it's always recommended to consult the manual if you of the transmitter if you wanted to go into details on the HART function. In our case, the range we suppose it was 0 to 100, but we see that the range or the URV, the upper range, is 101 degrees Celsius. This might be the cause of having the error at full scale. So simply, if I need to change it, just press on that. I can change it to 100. Okay. So the value now is not changing on the transmitter because it's still in yellow. Still in yellow means that it is not applied yet, it's not sent or transmitted to the device. So if I did any mistake, I simply can press on the cross and it will cancel all the modifications without saving them. If I press on the tick here, after doing any modification, all will go, or it will be applied immediately. So this is one option how we change the range. The other option is very useful because we have a calibrator here with the communicator. We have standard values for the readings. So instead of inputting the LRV and URV by hand or as a key input, as a keypad input, I can do this from the calibrator on actual value. So I can apply the values of the URV and LRV. Here from the online device setup, I have process variables, diagnostics, basic setup, detailed setup, review. So I have a lot of functions. Let me go for diagnostics and services. I have calibration, sensor trim if I want to do a trim. So I have also a way to adjust. If I wanted to adjust the transmitter, I can simply do a trimming from here. So here is the option to do the trim on the transmitter sensor. Let me go to calibration. See, I can apply values or range values. The range values will give me the limits of the transmitter. So the minimum is minus 200, the maximum is 850. These are the minimum maximum settings for the channel. And here I can edit the readings or edit the LRV, URV by the key input as we did in the previous exercise. I can also change the unit from here, but I'll show you how to do it in different way. So I can apply values. It will give me a warning that this will remove the device from the loop control. That's fine. So set the 4 milliampere. I have to set the 4 milliampere now. So I will set up the input, the RTD input, which is equivalent or relative to the 4 milliampere. So I will set it to 0. It's already set to 0. Back to the HART. Okay. I need to apply the new value. It's already applied for the 4 milliampere. Now it's 0.07 degrees Celsius. This is how the transmitter responds. So it will be set up as a 4 milliampere. So I have now the option to set up the 20 milliampere. So from the menu here, I'll select the 20 milliampere now. So I need to set the 20 milliampere. Apply the new 20 milliampere input, switch application. Okay, we are in HART, right? So I need to apply the 100 now. As we can see, it's now set to give 19.85, but after we adjust that, we apply that. So it's 100.08. So there is a trim here, as you can. There is a deviation of 0.07 here. That was the error in the transmitter. Now all will go when we do the rearranging by this way. So no need to now exit. No need to make a calibration, then make adjustment. No, I have both devices in one. I have both calibrator and communicator in one device, so I am good to do that in one shot. Okay, so now we are done with the adjustment. Okay, so this is the rearranging. Either I do it on keypad input, or I do it on actual from a calibrator. Doing that on actual from the calibrator will help you get the right compensation of the ambient temperature. So if the device is in a hot area or a relatively warm area, or if it's in a cold place, then I'll apply the actual 0, the actual 100, considering the atmosphere. So no need to do a compensation by calculation, then apply it by keypad input. You can simply utilize the calibrator function to do that on real time. Okay, let's see how can we, for example, do a loop test. So here, in coming back to diagnostics and services, here is the loop test. So if you wanted to make a loop test, if the device is already installed and you wanted to test the loop, you simply press here and it will perform you the 4 milliampere and the 20 milliampere. And this will be injected from channel 2, means that it is also a calibrated signal. So I'll abort that because I'm not connected to a network now. Okay, aborted. Good. Then these are the basic HART functions people are considering. Let's, for example, change the type of the sensor, for example. So basic setup, sensor 1 configure. I can change the type. It's already now set to PT100. I can change it. PT1000, PT200, ohm, millivolt, thermocouple. So all of the options that the transmitter can apply, I will find them here. So I'll keep it on PT100. Let's change it, for example, to PT1000. Okay. It looks like it's not in the transmitter. PT200, PT500, these are uncommon things which we have never seen before. I don't know about you, but I have never came across. Okay, or you can change it to thermocouple. Abort, no need. Okay, you can also change the configuration, 2 wires, 3 wires, or 4 wires. You can change the unit as well. So this device gives us 3 options or 4 options: Celsius, Fahrenheit, R or K. So these are the basic HART functions. Let's browse and see more about setup. So in detailed setup, we have the temperature sensor, trim, signal conditioning, output conditioning, all of the HART functions. So it's a fully functional HART communicator. These are the diagnostics: the tag number, serial number, date, manufacturing date, manufacturer. So these are all set by the manufacturer. What's good in the DPI 620 Genie over the other process communicators is you have the power supply in, you have the HART resistor in. In addition to that, the device is functioning all DD files by various manufacturers. If you want to upgrade the DD library later on, you have the choice to do that free of charge. Our device is having a USB connection from the side, so you simply download the DD file from our website or from the a specific manufacturer if you want. Then you can just apply it, upgrade it by copying and pasting the files to the right place in the internal SD card. In addition to that, the license for the HART is paid by us. It's paid by GE Druck, so no need to worry about relicensing. The device will not stop working after some time, asking you to purchase an extension for the license. Druck is offering the HART free of charge for the whole life. This was a quick brief on the HART. The next video we will see how can we make the HART, or what type of HART connections we have on the DPI 620 Genie IS, the intrinsically safe version. Thank you.